Welcome back to the Compassionate Capitalist Show. I'm excited today. I'm always excited, of course, because it's my show and I get to choose my guests. So, of course, I'm always excited about my guests. But today we are really going to be focusing on something that has, the whole idea behind compassionate capitalism is putting money to work where it's solving problems and making our world a better place. And you can't have a better, higher definition, in my opinion. I guess it would probably be equal. You cure cancer, but do you solve our climate crisis? Can we solve our climate crisis so that humanity continues on for our next generation? And that is what we're going to be talking about today, because we are at if you haven't heard the term tipping point, you haven't watched any of the documentaries that are on TV or any of the things that are talking about these tipping points. And tipping points is when there's a huge environmental impact that causes the total destruction of some aspect. And there's like a spoken wheel of the different tipping points, but they have um this compounding effect where they one affects the other. And so some of the stuff that we've seen is like in the Arctic ice sheets are melting, and as they melt, they release other carbon out of the ocean of decayed biomass that has an acceleration of different other things. We have the death of the rainforest, particularly down in the Amazon, which were also because Mother Nature and our planet Earth has been able to heal itself over time. We have geological catastrophic events that they can trace back to when certain things and whole species became extinct and things like that. And there was certain things that happened, but as the rise of humanity and our use of energy to charge our lives, our love of fossil fuels in transportation industry to go to this place or that place, we've had an acceleration, and Mother Earth has not been able to really keep up. And so that's where these tipping points are happening, and things that would have had natural ways prior to, I think, and my guest today is going to be able to probably give me the exact statistics, but really since the industrial age of the 1920s and the turn of the century, did we, because all boats prior to the industrial age were wind. They used wind to get around, right? When we use natural resources naturally, and then we wanted to do things faster, bigger, better, but the invention of using combustion engines really changed that. So now we have the coral reefs that are dying because of the warming of the oceans and the coastal beaches, which is leading to the decline of fish population, which is, a big source of our food, but also everything is integrated. So sea turtles, even sharks, after millions of years, sharks population are noticeably declining. Insects are our pollinators, and they renew things. They eat up stuff and decay it, and they do all this as natural piece. And I'm really using a lot of layman's language here, but it's they make up 80% of the living entities and have seen a 41% decline in the last decade. It is real, right? And we finally, the problem that we have, and this is something that's it's native to free enterprise system, and I talk about it in my book. We talk about it on this podcast all the time with angel investors and venture capitalists. And these are people, they want to make money solving big problems in big markets, but sometimes the cost of solving those problems and in those markets is a really high bar. And so you can't just have capitalists or businesses deciding to innovate in this way. It has to be a combination of public-private partnership along with incentives from our government to encourage free enterprise to go this way, to use them to make changes in their own thing, like not using coal, but using some sustainable things like that, right? And there's, it's not enough. We're at that tipping point that it's not enough to just stop using fossil fuels, because we have to in effect, help Mother Nature do what she would have done to reverse or to heal our planet and stuff, right? So the real need for compassionate capitalists is investing to make money that has an impact and make a world a better place in all aspects, not just climate. But this is where the apex of change and opportunity is happening. And in the tradition of great tech solving real human problems, there are some solutions. We're going to talk about some of those today, but will they get commercialized in time? Because we are racing against the clock. And if you don't believe in climate change, you probably have turned off this podcast at this point in time. But I want to encourage you to listen too, because Iris Tenhav is my guest today. I'm going to do my formal introduction to her, but she knows this stuff and has committed her life to helping solve these problems and helping the people with the money know how to best solve these problems that not only can be successful, because every investment has this commercialization process, right? So there's figuring out how to solve it and then how building it to scale. Like some of the things that I looked at in preparation, so like these big giant vacuums that like are sucking carbon out and then converting it into something else out of our atmosphere, right? The U.S. Department of Energy, our U.S. government, this is where we're putting the money where our mouth is, because we've not invested in this kind of stuff. We've done some things through our SBIRs, which are grants to help development, but that's really just kind of like prototyping. It's really not large commercialization. It takes private money to do the large commercialization and customers finding out who is going to be a customer for that technology. But through the bipartisan infrastructure bill and the Inflation Reduction Act, we are creating a new economy of jobs and investment incentives, and the government being the anchor, the anchor tenant in some ways and something like this. So the U.S. Department of Energy has announced a massive investment in directing air carbon removal projects that 3.5 billion from that bill into this. So, but I looked at it in there, and I believe Iris is going to tell us about some of their investments, but I looked at this one plant up in Greenland. And our goal out of this, the goal of the U.S. government, is to remove 1 million tons of CO2 per year, which is equivalent of taking the carbon produced on gas-powered cars, 200,000 cars off the road. That's the equivalent of it, right? But this one giant plant, it's like the largest so far, I think, in Iceland, does 4,000. It's doing 4,000 tons of carbon a year, but that's only 800 cars. So that's a big gap. There's a lot of investment that needs to be done in that. And I would venture to say that $3.5 billion is not enough. And that's the reason why we need organizations like that. Iris Tenhav is part of. Extantia is her, this is the venture capital fund that she works with. So we're going to talk a lot about some of these really incredible, innovative solutions, ways that they're doing stuff to repopulate and help our largest body of water, our oceans, do the things that it has done, all this kind of stuff. So let me tell you about Iris. She's waiting patiently for those that are watching on YouTube. She's been sitting there just sort of smiling nicely at me. So she is the head of science at Extantia Capital. She's a trained chemist. And before any of you go, chemist, wow, yeah, okay, it's not, and but the train has turned into climate tech venture capital investor, right? So chemistry, so much about all of this stuff, the whole nature of what carbon is. If you remember back to your high school days, when you learned the elements table, carbon is an element on the elements table, and it is an element that is part of so many other things like CO2 and all this kind of stuff. And so when I kick this off and I turn the mic over to her, to Iris, she's going to give us the 101 lesson of this, right? And so, it is so critical. And I've interviewed other people on this show that are creating consortiums of venture capitalists that want to, and private investors. But I want to encourage all of the investors that are listening here today. If you are not directly involved in solving a problem in your portfolio of climate change, then you need to be invested in funds that are doing this, that you can put your money to work to help those brains, those people that are seeing it at a bigger level, that have the wherewithal to take on the challenges and be a part of the solution for that. So that's my call to action. And now I'm going to say, hi, welcome, Iris. Thank you so much for being on the Compassionate Capitalist Show.
Hi, Karen. Thanks a lot for the introduction. I loved your story, and that's such a good overview. And I love the call to action at the end. Please continue with these kind of things. Yeah, I'll
Yeah.
do a quick overview of how I got here. As you said, I'm essentially a trained chemist that turned to the dark side. But the dark side, also known as venture
Is the
capital,
light.
yeah, that is currently the life that I'm living. But I turned to the dark side with good intentions, you know. I'm currently, as you said, devoting my life to making a significant dent in climate change. And I'm currently head of science at Extantia Capital. We're a climate tech venture capital firm based in Berlin, Germany. And head of science is actually quite an uncommon position for a venture capital fund. So most people know venture capital from massive gains in the software industry in Silicon Valley. But for us, there's actually a reason that our fund needs a head of science. So at Extantia, we want to solve big problems. And so what does a big problem mean to us? A big problem are sectors that emit at least 1 gigatons of CO2 equivalents per year. So with our investments, we want to address these sectors. And because we have a CO2 emission saving mandate, we almost exclusively invest in the hardware space. Just imagine it this way. We believe that greenhouse gases just cannot be removed from the physical atmosphere with just another app on your phone, you know? And this is why I, as a chemist, am deeply involved in the investment decision-making process of a venture capital firm. And it's not just investment bankers this time, you know, it's also chemists like myself. And yeah, as you mentioned already, Karen, so the CO2 levels in our atmosphere have almost doubled since the industrial age. And why is this a problem? Well, carbon is good on the one hand, it's a source of life, it's a source of energy. So why does it actually cause climate change, right? So us as humans, we've been burning fossil fuels like coal or oil or natural gas essentially since the industrial age. And although that was essential for us building up the economy as we know it right now, it has also significantly increased the concentration of carbon dioxide in the atmosphere. So when these fuels are burned for energy, carbon dioxide is released as a byproduct in the air. And the excess of carbon dioxide in the atmosphere acts like a kind of blanket. So you can see it as a blanket trapping more and more heat because it's kind of covering our globe. And that's causing the Earth's temperature to rise. Now, this phenomenon is commonly referred to as global warming. And the increase in temperature will eventually lead to climate change and other adverse impacts. So I guess, you know, we've all seen the news in the past years about, like rising temperatures, less predictable weather patterns like storms and extreme weather events, droughts, ocean acidification, all these kind of things. And that's essentially what greenhouse gases, of which carbon dioxide is one, but there are also other greenhouse gases like methane or nitrous oxides that can have similar effects. And on the long term, our kind of human activities are linked to the climate change as we know it.
So I remember back, and so some people may remember, like, I think when Al Gore started to try to draw attention to this, you know, a while ago, and there was this thing where ozone layer and stop using hairspray and go to non-aerosol. So connect the dots between the what happens with this seal, because the ozone layer was like, oh, there's not a filter, so there's more sun coming in, and now it's sort of like it's a ceiling that keeps the heat trapped. So connect the dots, and either it's new science or it's just better under science, or they're completely separate issues.
No, I think we slowly started to understand the issues better over the past years. And I think there's now, at least amongst the science community, but also in some of the investor communities like climate tech, there's this sort of common understanding that carbon dioxide, but also other greenhouse gases are like, it's a bit like when you're laying in bed in the summer and you have this hot blanket around you that's just like way too thick. And this is what we're constantly doing every day when we're driving our cars or flying planes. We're just adding to that blanket or making the blanket thicker and thicker. and making the planet warmer and warmer. So
okay, so the stuff from back with the ozone depletion is being replaced by this lingering carbon dioxide.
I wouldn't say it's being replaced. The ozone layer issue was at the time, as far as I understood, it's not my field of expertise, but mostly caused by this hydrofluorocarbons that we used, for example, in compressor-based cooling systems. And slowly, through regulations, we started phasing out these kind of hydrofluorocarbons. And that's how part of
Okay.
that issue, at least, was mitigated.
Yeah. Okay. So let's get into, because now on your website you have a Giga-corn. Is that referencing the opportunity, or when you said something at the start about how much carbon you're trying to take out of the atmosphere?
Yeah, correct. So Giga-corn is a term that we're using. So typically in venture capital, people would say we're looking for unicorns. And a unicorn is
Yeah.
then a company that's worth $1 billion or euros. But we want, let's say, a unicorn that also saves or addresses a gigaton problem. So that's when we use the term Giga-corn. So that's where
Oh,
it comes
okay.
from.
I get it. I get
Yeah.
it. Oh, they're very clever. Okay. All right. So, most people, when they think of hardware, and that's y'all's focus mostly is on the hardware side, people think of hardware like myself, I'm wrapping my head around these big machines, and I think of hardware as like computers or, an assembly line or, robotics or something like that. So, I mean, is it what happens like on that example I used at the beginning? Is it just literally sucking atmosphere out and then cleaning it and putting it back, or like what? Talk about some of these different ways that hardware marries up with chemistry to start to reverse this cycle as we work towards not producing as much carbon by making us less fossil fuel dependent, right? So we're changing people's behaviors and habits and technology advances, but also fixing things. So you're on the side primarily of fixing things, right?
Well, I mean, ideally we would be on both sides, also from a fund perspective. But maybe let's use that example indeed, Karen, where that we already kind of discussed personally a little bit, the direct air capture. So as you also mentioned in your introduction, is that the US has now devoted $3.5 billion to direct air capture, or at least to carbon capture in one way or another. And this is actually this is yeah, it's on the side of fixing problems. So the idea is to suck carbon dioxide out of the air. But it's a good example to illustrate how hardware is actually super important for the climate. Because with an app on your phone or a website, you simply cannot remove CO2 emissions. So think of it this way. It's you could see it like maybe a big vacuum cleaner, right? You have at the moment one of the biggest plants operating in the world right now is actually Climeworks. You might have heard of that one. They have this huge kind of plant. It looks a little bit like a stereo almost, or you could imagine it as a vacuum cleaner. So you need these pieces of hardware that ventilate the air through the system. And when the air is ventilated through the system, the carbon dioxide can be absorbed by things that we would call a sorbent. And that sorbent has very specific sort of linkers that can bind with the CO2 and kind of hold it in that sorbent. And once the CO2 is absorbed by the sorbent, the air that comes out on the other side of the vacuum cleaner doesn't have as much CO2 anymore. So we've actually captured that CO2 from the air. And what actually happens in the sorbent is like chemistry, what you're saying. So maybe a better term to describe it, it's actually like chemical engineering, where you kind of use a reactor, and the chemistry that's happening is on the inside of the reactor, right? That is where the CO2 actually gets absorbed and stays, and then can then be sort of regenerated off of that sorbent, and then the sorbent can be reused again. So that's indeed one of the examples where hardware is for us something different than a computer or like robotics. These
Yeah.
things can come in climate, they totally can. But from us, we start thinking from, let's say, the big reactors or the direct air capture plants.
Okay. So like in that example, and this is like a while back, you know, I'm anticipating the naysayers, right?
Yeah.
So it's like when we started to see people wanting to move towards corn biofuels, right? And then there was the whole thing about, well, it costs so much energy to produce that is it really having a net positive effect? So in this case, given how much it can capture, and then it's like, well, if the air's right around it's clean, but now you're saying, because it's not, so it's a constant of contaminated air that is then captured and released. So, it's like like they pump the clean air a mile down the road, or like I'm just trying to get a sense of, as a layman, how that works. And then it seems like it would require a lot of energy.
Yeah.
So is it getting enough energy from a non-fossil fuel energy to source to be able to do this processing of what this plant does,
Yeah.
right? So kind of like,
Yeah.
those
No, it's
elements of it. And then does the byproduct, I've seen some places where then they go and they bury it, but then it seems like we're sort of creating we're just kicking the can down the road on a problem that has to be addressed, unless the byproduct is something that they're using to do something someplace else, like in the ocean, that then provides a regenerative effect on something that's happening someplace else.
Yeah, no, that's a great point. And maybe let's get back to, let's say, the vacuum cleaner as sort of an example, right, or an analogy. So in this case of direct air capture, what actually costs more energy is sort of cleaning the vacuum cleaner. So as you're saying, like the air moves through, at some point the sorbent or the vacuum cleaner is full and it needs to be emptied, so to say. But the CO2 that's absorbed on the sorbent is actually sticking to the sorbent, and to release it from the sorbent, we need to put in a lot of energy. So this is, for most direct air capture technologies, the main issue why it's not being commercialized yet at very large scale. It costs a lot of energy to release the CO2 again from the sorbent, or to clean the vacuum cleaner, so to say. And it costs so much energy that it also makes it very expensive. And when something is very expensive, people typically don't want to do it, because we need to put in
Right.
so much energy that it costs a lot of money. And therefore, at the moment, it costs, I think, around
That's the
$800 per
rub.
ton of CO2. Yeah. So again, money makes the world go round. But yeah, in this example, I would say at the moment, we don't have enough renewable energy to do this kind of stuff, to clean the vacuum cleaner over and over again. So what is actually important in terms of technological developments, that we drive down the energy needed. Like, we need to develop a better vacuum cleaner that's easier to clean, so to say. And once we are there, then we can deploy it at much larger scales, because right now it's just really expensive because of the high energy input needed. um, and yeah, I also heard you say, Karen, that the bioenergy example. So in the US, of course, there's been, yeah, corn has also been used for biofuels. And there was this whole debate going on. Okay, should we use corn for food, or should we use corn for fuel? Is it actually worth it? Because we're putting in so much energy to do this. And I think, at least at our firm, if we're looking at things in the bioenergy space, which are sometimes of interest to us, because especially here in Germany, biogas is quite an important source of energy. Then we want to make sure that the input used to create the bioenergy is sustainable. So we don't actually want the input to be competing with food that as humans eat. So you can make bioenergy and it can be profitable and sustainable, but you need to make sure that what you make the bioenergy from is a sustainable source. So think, for example, of municipal waste. Like, if we use our waste, or either our municipal waste or agricultural waste, a sustainable way of creating energy.
Okay,
Yeah.
so and I think you guys have done some investments in synthetic fuels and green hydrogen. Is that right?
Yeah, that's correct
So
indeed. Yeah.
that seems like that's complementary to what you're doing with the carbon renewal. Is that part of it, where like it hasn't yet been able to figure out how to use the synthetic fuels or the green hydrogen to to power those kind of plants, and that's the innovation that sort of like the problem that you guys are working on solving as well with the innovators out there.
Yeah, correct. So, and I think what you're mentioning, synthetic fuels, are, for example, what we would refer to that as a drop-in fuel. So what does that mean, a drop-in fuel? From a chemist point of view, a drop-in fuel means that it is exactly the same molecule as that is currently used in, let's say, a car or a plane. So currently planes are flying on kerosene, and the company that we've invested in that makes e-fuels, they're called Ineratech. They're here in Germany. They instead of making this kerosene from fossil-based resources, they make the kerosene from carbon dioxide directly. And that kerosene is the exact same molecule as what you would essentially get at the gas station. So they can just drop it in the plane, just like this, without changing any infrastructure, essentially. And that's why we like these kind of drop-in solutions so much, because we don't necessarily need to invest in new infrastructure to make flying more sustainable in that sense. And the other thing that you mentioned, so the green hydrogen, we've also indeed done an investment in that space, H2 Pro, based in Israel. Green hydrogen and producing green hydrogen also at the moment comes down to cost, I would say. So a lot of companies out there can make green hydrogen from sustainable sources, for maybe, well, in Europe, maybe like 6, 7, 8 euros per kilogram, which is way too expensive. So we need to drive down these costs, which essentially typically means we need to drive down the energy input of this process to make the market adopt it. And then even if the market adopts this solution, right now, the infrastructure for green hydrogen as sort of an well-adopted fuel is not really there yet. So green hydrogen and its usage in planes, for example, I mean, maybe it will happen in decades from now, but right now it's just not quick enough to really compete and to scale up and to create the infrastructure so that planes can fly on hydrogen. So right now, yeah, we find green hydrogen is important for the future, but sort of to really make quick moves and to make, for example, flying more sustainable quickly, we like things that are drop-in solutions, so like e-fuels.
Yeah, so the e-fuels being the synthetic fuels. Is that
Yeah,
the
the synthetic
e-fuels?
fuels, yeah, so
So
could
is
be
there a way?
created from CO2, but could also be created from biomass, for example,
Yeah.
EO2.
So it seems to me that connecting the dots behind cleaning and taking carbon out of the CO2 out of the air could almost become self-fueling in a way if you had the right hardware to do that. Am I making a leap there? That's
No, you're not making any leap at all. That's actually exactly how we would envision it to work in the long run, right? Where, for example, our e-fuels company, Ineratech, takes the carbon dioxide from a direct air company and uses that exact carbon dioxide that was just sucked out of the air to create e-fuels. And then when they're emitted again when we're flying, they should again be sort of taken out of the air. And then it becomes more like a circular economy instead of a linear economy where we're currently polluting, and not fixing.
yeah.
So that's of course like that's our vision. That's how we would like things to be.
So that's so then that becomes a lot of what I guess Estancia is funding is there's the commercialization side, but there's also the figuring out side, the true R&D of, testing theories. Here's a hypothesis. Let's see if we can create it. And that is in companies that you've backed that have those kind of R&D departments, or is it also coming out of universities that might get picked up by some of these commercialized companies? Where you see the innovation happening that you guys are trying to build up?
Yeah, that's also a good question. I think innovation is currently happening on multiple fronts, but for us, because we're a relatively early stage investor, so we would typically take on seed or Series A investments. That means that for us, a lot of the innovations that we like backing come out of technical universities. So yeah, imagine like a team of students or scientists that have found something out, and they worked for years, supported by research grants, for example, and they're now ready. They have like a prototype in the lab, and they're now ready to commercialize it. That's when
Yeah.
we come in as a venture capital fund, and that's where we provide kind of the type of support and financing that research grants are typically not focused on.
Yeah, we had, and it's something that's interesting. Have you found that corporate R&D or corporate venture funds are aligned. So like, let me give you an example. So years ago when I was running the angel investor group, we had a company come through that had invented a way for to take plastics, like all your, the grocery bags and the dry cleaning bags and all a styrofoam and all the stuff that is considered non-recyclable, and it would convert it back to its original petroleum base, and it would could get to diesel. Exactly, was the easiest kind of grade to get to, and it could take, it took a lot of that in order to like make, a quart, right? But they had a prototype that you could make a quart, put in massive amount of this stuff, and they really struggled because this was, this is actually probably 20 years ago that and so, the appreciation for the challenge and what was needed wasn't as, as large scale as it is now. And so, and the cost, the private investors, it was like, oh, it was going to take, we need we need $5 million just to build one that will do a drum of that, right?
Yeah.
And the whole supply chain of how do I get, because there's plenty of it's in our dumps, but how do I get enough of this stuff to be able to come in to do this, right? And ultimately they went over to Saudi Arabia to try to get funding. They went all over the place trying to get funding, and finally it was some BP execs that invested in it. And I've never seen the technology today. I don't know if it's out there someplace trying to be scaled, but I always suspected that the BP execs buried it. And
Yeah.
so, do you see, because of awareness, is sort of like, because earlier you said the dark side, right?
Yeah.
So your estancia is, a knight in shining armor, trying to solve these problems versus trying to squash the problems or be a shark, if you will, to like, be manipulative in the innovation. And what happens is there a turning of tide of capital that says we need to allocate a certain amount to this, we do need to participate in these solutions, it's inevitable, so we want to have a seat at the table? I mean, I've seen a change in some of that, but it could be just because I'm more aware, right? So are you in the industry, deep in the industry, are you seeing a lot more collaborative and uplifting and not always just what's in it for me kind of a mode?
Yeah, that's a good example, actually, Karen. So the plastic to diesel example that you saw, you said decades ago, I believe. I think also at that time maybe the market wasn't ready for it, and as you said, they were scaring off like venture capitalists by saying, "Oh, we need 5 million for this plant," and that essentially means that they just didn't have the right support at that time, and maybe even more important, there was also not like the right logistics for this to happen were
Yeah.
just not in place, right? They couldn't collect the right waste, in this case plastic, that they needed. So yeah, I think how we see it, look at the moment, people, these types of technologies, I don't think I would say it like they are buried by companies, but I think I would rather say it as they might exist, but they are not commercially, they were maybe not commercially relevant yet because they were too expensive. So as we talked about before, right, creating diesel
Okay.
from plastic, it could very well have been that that cost more energy to put in than they got out. So that means essentially that yeah, the market wasn't ready. Probably the technology maybe had some work to do still. So
Yeah.
I'm assuming it would have cost a lot of energy. And if it costs a lot of energy, it costs a lot of money. And that's when companies, but also the world, essentially doesn't want to do it, right?
Yeah.
So, and this is not the only example of technology that has existed for decades, but wasn't commercially available or not commercially relevant. And that boils down to money in that case. It's the same, for example, with the company Ineratech that we've invested in, and they're making e-fuels from CO2. The technology for this is essentially a century old. It has existed for a very long time and was even used in the Second World War already to create fuel when the Germans, in this case, didn't have access to coal and natural gas. And then the sort of popularity and excitement around this technology died down again when the world wars were over and when we had enough oil available, right? So it comes down to a balance of multiple factors, I would say. So I also think we do see collaborative efforts, and especially when, yeah, what we said, when there's something in it, right? When it, yeah, sort of it has to be presented in a way that it is a great market opportunity, which I think it is. Climate tech is the next sort of multi-trillion market opportunity.
It's a gigacorn.
It's a giga-corn. Well, the company should be a giga-corn indeed. Yeah, hopefully we'll see many herds of giga-corns in the coming years.
Yes,
Yeah.
absolutely. So what when you guys look at, because you said seed stage, so define for our audience what is seed stage to Extantia? Like
Yeah.
how far does the company have to have gotten? Is it like pure commercialization out of an R&D and it's a newly formed company, or does it really have to have more traction? And then sort of, what's the appetite for that? Because like some places will do a little bit of money, see how they do. If they do well, then they get more money and they get more money. Or do you kind of, have a higher bar and you just do more money because you've got a dot that you've got on the thing. We need to find a solution to this problem, and here's the different ways to go about getting to it. And so we're looking for companies that are doing XYZ, and then we'll,
Yeah.
or is it both? Is it both approaches?
Yeah, I think so. Seed stage, it's also the whole terminology becomes a bit confusing if you
Yeah.
are used to software, I think.
Yeah.
So for us, seed stage would mean that a company has at least like a TRL4 prototype. So like a prototype in the lab that's working, and let's say the technology is de-risked. So the science behind it has been proven, at least on a laboratory scale. That's
Okay.
when they're, in our eyes, kind of ready for a seed investment. And so the prototype and like de-risking the science is on them, because we are kind of here. We are here actually to build a great company from a great product, and that great product and that invention has to be there already before we can step in. And if that's not there yet, then they essentially have to go back to the lab, get more grants, and de-risk the science, so to say. Is we are willing to take engineering risk and like engineering risks and helping with scale up procedures and creating traction with the company together. That's what you do as a venture capitalist, so to say. But yeah, knowing how to build the prototype and de-risking the science, that's on the entrepreneurs in most cases. So yeah,
Okay.
for us, through our eyes, a seed stage is when they have at least a prototype in the lab that's working, and then we can come in and help them with the commercialization.
So you
Doesn't
provide the knowledge, because like your
Yeah.
team, knowledge as well as financial resources, like physical, intellectual, and financial resources.
Yeah, I guess one could say smart capital in a way, because typically entrepreneurs that are working in the hardware space in climate tech, they don't just need money, but they also need help with scaling up. And that can be, for example, connecting them to the right partners for scaling up and to solve these engineering issues, so to say, or connecting them to the right, yeah, blue collar workers or engineers, if you want to say it like that. So we have expertise in that space, and we would, yeah, typically refer to it as smart capital, not just money, but also support with scaling up, which is very necessary with a lot of these inventions.
And as we start to wrap up, give I want to tell everybody, go check out the website. And I've got some other links in the show notes for you to be able to connect up with Iris on LinkedIn and whatnot. And she has a blog that she does, but Extantia is EXTANTIA.com.
Correct.
Extantia. So is that to talk about the origins of Extantia, because we didn't really get into that at the beginning. We just dove right into the climate problems and the solutions. And how long has Extantia been working on trying to solve this, and what was the origins? How did it come about to be such a substantial payment, and what's like how much money under management and has been deployed? Just give some of those nuts and bolts of
Yeah.
who you're working with.
Yeah, of course. So yeah, we haven't really talked about that from the get-go, but I think what brought the Extantia founders together was actually frustration. So after the Paris Climate Conference that took place in
Mm-hmm.
2015, climate tech was growing, but in Europe we were looking at North America and we saw investments being done in the space, but that, yeah, created sort of the founders of Extantia to really see a gap in the market, like a missing puzzle piece, so to say. And yeah, they wanted to create a firm in Europe that is cultivating climate tech, and that was really missing. And it shouldn't just be like a mainstream fund, they were thinking, but it has to be a dedicated fund. That was what was needed actually. So yeah, and that's what eventually, so the sort of the whole frustration around that missing was what brought the founders together back in 2019. And yeah, we started off with like a pilot fund, and at the moment we have about 100 million euros under management. And our fund structure, it actually consists of two funds. So we have 150 million euros fund for direct investments that goes to startups. And then we also have a 150 million fund that goes to other funds. So we're also a fund investor. So
Oh, a fund
investing
of
in
funds.
both climate tech startups and also other climate tech funds. Yeah.
Very good. And then in those cases, also hardware, or is that where, since you focus on hardware, you're looking to them to do, I mean, and it's separate, I get not software, whatever kind of a stuff, but thinking of hardware in the terms of hardcore like plants and, like the vacuum example we've been using,
Yeah.
or other sort of space, because I've seen some where they're focusing on, hydropower, for example, and more efficient use of water, and the output of water that, is not contaminated. So they're solving, water for livelihood along with power. But I guess that's a
Yeah.
hardware element in that as well. So everything really kind of has a hardware element into it.
Yeah, and in a lot of cases, hardware has to be combined with software in some way, right? So also maybe want to make that clear that we're not against software. We think it should be there. Like it can really help with optimizing processes in that sense. It just shouldn't be the main contributor to saving climate change. But I can give you a few examples of fund investments that we've done. So us at Extensia, we're like a team of engineers, mathematicians, chemists, and entrepreneurs. So we're quite strong in sort of the chemical industry type investments, things that fit in a container and convert X to Y essentially. But we don't see ourselves as very strong investors in the food and agriculture space. And that's when we decided to invest in a Belgian fund called Astenor, who do investments in the food and agriculture space. So it's very
Okay.
complementary to our personal skills. And the same, we have done something like this on a similar level with investment stage. So we do seed and Series A, but we've also invested in a fund in the UK called Zero Carbon Capital, and they do pre-seed and seed investments. So that means if I, for example, see a deal and I'm really excited about it, but it's too early for our fund, I can talk to Zero Carbon Capital and they can give it a shot maybe. So yeah, it has many different advantages, I would say, to be both a startup and a fund investor.
Okay. So as we start to wrap up here, anything that we haven't talked about that you're like, oh, really want this audience to understand this aspect or this thing when it comes to thinking about climate investing?
Yeah, so I could imagine that a big part of the audience will be other investors and venture capitalists. So maybe just to emphasize that one more time, software is important, but greenhouse gases cannot be removed from the physical atmosphere with an app on your phone. So we actually need hardware to solve the climate crisis. And therefore, we will need more capital, which needs to be invested for longer periods of times. And last but not least, we will also need more expertise in this space, right? So me as a chemist that moved to venture capital, but I also hope to see maybe many of my science colleagues that move into the space someday, or many of my science colleagues that will become entrepreneurs in the space, because we need this type of expertise to solve the actual problem.
Yeah. And patient capital, but we still really only have about 2 decades at the most to stop some of these tipping points, right?
Exactly. So yeah, let's say a kilogram of carbon saved today is worth more than a kilogram of carbon saved tomorrow.
Yeah. Yeah,
There you go.
totally. There you go. So yeah, I absolutely, I hope for more, and when you look at, it's the whole basic premise of, how capitalism, free enterprise, the risk and reward, all that kind of stuff. And but as I tell people, the reason why people become angel investors and then become venture capitalists, it's an order of magnitude of money differentiates angel investors and venture capital and the amount, and then other people have invested in that. So there's like the fundamental direct investment, my money through somebody else who's smarter and got a better team to solve these other kind of problems, right, kind of a thing, and bigger impact. And so you have to, that's all kind of part of it. But the real reason why people choose to do any of this kind of investing, versus just real estate investing or just making money on the stock market. People can make money on the stock market. People make money on stuff. It's because of how it makes them feel. It's because they know that their dollars are having a greater impact to make life better. That is the compassionate capitalism mantra. And that is why people need to come into this, be patient with it, do the right due diligence, to find where it's aligned, right? To be able to invest in these kinds of things, but, go after trying to figure out how to put your dollars to work to have an impact. So if you're a real estate investor, stock investor, toying with becoming an entrepreneur investor or an innovation investor, then, figure out a way to play and have that as a component of your portfolio. Every company should have a component of that portfolio. And even on the public stock side, there are public stock funds out there that do focus on this area of climate. So if you're putting your toe in the water as an industry, you can start there and then work your way up to having a true impact, which is investing directly in the innovation on this stuff. So that's a big call to action for folks, and really want you to go and spend some time on Extantia's site. Go to the blog, which you'll see it's too many letters to say out loud, but it's really Irish Tin Have. Now you have a C in the middle of that. I'm sorry. Irish C Tin Have .medium.com. Is that right? Because I think I copied and pasted that right. Okay.
Correct.
I just wanted to make sure that that's right. And so you talk on your blog, you talk about things that you're involved in, trends and stuff. What do you share on your blog?
Yeah, it's for example, some of the trends that we see, or some of the trends that we're excited about for the upcoming period. So that can be quarters, years, etc. And also we share insights of deep dives in specific topics in climate tech that we're doing internally here at the fund. So in the past year, we've done, for example, CO2 conversion, we've done green ammonia, a whole bunch of other things. Check it out, I would say.
So are there any of your investments that are in the have they made that pivot point or whatever of going from a R&D, innovation, validation kind of a thing, but are actually have gotten to a point where they're sustaining themselves, and or is it too soon?
Yeah, I would say it's a little bit early, but for some of the companies that we've invested in, we've seen great progress happening actually. But to really say that look, with hardware it just takes longer. So it doesn't just depend on a few software engineers sitting in their basement and coding. It depends on actual parts being shipped from one place to the next. So you can say, okay, we want to make it work in a year, but you cannot always control that. However, for some of the companies we've invested in, we've seen great traction happening where they had a huge pre-order book and things like that. So it's coming, but it will inevitably take a little bit more time than a software investment.
Are you seeing any innovation that's come out of the I just had this. I had to throw a last question in here. Innovation that's coming out of like the space travel sector, that in order to be able to do that, to go up and back, has there been any innovation that could then become something that might accelerate stuff that's happening down here on Earth when it comes to solving some of these climate things? If there's been any cross-pollination of any industry, not just that you've seen where they focused on solving something in this one area, and then it's had cross-purpose to help solve it in another area, different problem in a different area.
That's a great question. I would say with the space example, I don't think that's like the focus of our fund. But something that we've seen recently, for example, is a technology that used to be deployed for water treatment purposes that is slowly also gaining traction in the biogas space. So we can, for example, use that exact same technology to create bioenergy from waste resources, whereas
Okay.
it was back in the days only used for treating water. So this does happen, you know, that inventions were already there, but they weren't really commercialized in that field. And then a different field of like inspiring entrepreneurs picked up on it and used it for a different
Yeah.
purpose. And that's always really inspiring to see, I have to say.
Right. Well, and that would also seem like, I wonder if so do you have like a team, because you mentioned the uh what was it, biohydrant. I'm sorry, what was the green hydrogen had been
Green
around
hydrogen.
for the technology had been around for a long time, but they it hadn't really been, because of the cost associated with it. So do you have part of your fund are the folks that look at maybe patents and inventions that were done a while back but never got like, even like the example I gave before about that one, they got commercialized or they got a prototype done but the market wasn't ready, and you can kind of resurrect it and retest it to see if it's ready now? Is that an element of what you guys are doing as you're looking to solve this, or are you just sort of waiting for an entrepreneur to have done that and then bring it to you guys so that you can fund the rest of it?
Yeah, it's a good question. And indeed, the example of green hydrogen. So green hydrogen is typically, instead of made from fossil-based resources, it's made from water, right? So the first time that hydrogen was ever made from water was actually at the end of the 19th century by two Dutch merchants. So it's existed forever. It just wasn't commercially relevant. And I think us at Extensia, with kind of like our science-focused team, we do look for these kind of things, but it's we are not a venture builder, so it's not as if we go and then take the patent and try it ourselves. But sometimes we look around and see if there were any entrepreneurs or scientists that were working on it and then stopped working on it. And sometimes that's how we source deals, right? And you reach out to these people and apparently they're commercializing it, but they're in stealth mode, for example. So that has also brought a very interesting leads to the team, actually looking
Yeah.
for, let's say, early research or research that was like stopped at some point. Yeah, for sure.
Very good. Very good. Thank you so much for taking the time to share with my audience what you guys are doing over at Extantia, the challenges in the marketplace and how you're solving it. And really hope that even within my own relationships of folks that I've done, that I can help you guys in some way with this, because it's definitely, we all need these problems to be solved, right?
Yeah, yeah, Karen, thanks for creating this platform. I think the more often we talk about it and the more people are aware of it, the more people will realize that climate tech is the next multi-trillion-dollar market opportunity that you just don't want to miss out on. And that's the kind of atmosphere that we need to create in the coming decade. Thank
Yep.
you.
Thank you so very much. All right, everybody. Thank you for tuning in. See you next week again. Come back, share this with anybody you know that cares about the climate and those that should care about the climate. And with that, we're going to say onwards and upwards. Have a great day.